Sorry about that, guys. Apparently I had myself muted and I didn't even realize it. Well, alright, that's fine. It's not a big deal. I didn't really talk about too much. I just kind of went over the general structure of GitHub. Or not GitHub, but Git rather. And how it indexes files in the backend. But we can kind of go over that again. So for the benefit of any of you guys who've never been here before, and the benefit of the people who are probably watching on YouTube later down the line, my name is Tensor, and we're going to be building a sort of Git command line tool in Rust. And I'm thinking that we're probably going to only be able to implement maybe 2 or 3 different commands. There are a lot of different commands in the Git CLI. And yeah, it would, if we really wanted to implement all of them, we would be here all day, essentially. It'd be very, it'd be a very long live stream, to say the least. Now, this may be something that we want to do at some other point in the future, but I'm not really sure. We'll find out based on this live stream whether or not you guys are interested in seeing more. So you guys all hear me right, correct? I'm just making sure. I've got the chat here. No one's talked since I unmuted myself, so I'm just kind of a little curious if you can hear me or not. Okay, I got a yes from Not a Robot and from Chester. Thank you guys. I appreciate that. I'm sorry about all the technical snafus that tend to happen in my live streams. I tried something different today, and apparently it bit me in the ass. Anyway, I probably shouldn't use curse words on this, but whatever. I think we're all adults here. Alright, so before we get into this, I just want to show you guys the folder structure of a normal Git project. I'm going to open up the .git folder for this project. Now, by default, Visual Studio Code just, I think it hides it in the little directory here. So we can just go directly into it and take a look. Now, the files that we want to worry about are this index file and this heads file. The index file, you can see here, it's encrypted, and so we can't actually view the data inside of it. It's mainly just bytes and stuff. The heads file is essentially just a reference to where the current head of the repository is, and I'll kind of explain that as we're going in a little bit more detail. Just know that this does exist. And then we've got 2 pieces of metadata. We have the config, which is like the config for the actual repository, and then we have this description, which will be a description for the project that's inside of the repository. We're not going to worry about these 2 files with our implementation. We're also not going to be worrying about this commit edit message file either. This is essentially just when you make a commit on Git, you can add a message optionally. You don't have to, but you can. And this is where those messages go. Then we've got all these other folders here. We've got hooks, info, logs, objects, and refs. The ones that we're worried about are the objects folder and the refs folder. And even inside of the refs folder, we're not going to have a remotes folder because we're not going to be connecting to a remote repository like this one is. And we're not going to have a tags folder. And mainly we're just doing this to simplify things. Maybe in the future we'll add some kind of remote functionality, but for now, you know, because we're probably just going to be implementing init, add, and commit, there's really no reason to have some kind of remote repository. Now inside of the heads folder, we've got a master file and it's got this hash in it. The hash is essentially just the reference of where we are in the repository currently. Then if you look here, it's also the same hash. So you can see here that the local repository and the remote repository have the same hash. Therefore, they should be completely synced together. Then inside of objects here, we've got a bunch of different files. You can see they're all kind of encoded in a strange way. This is what's called libz encoding. We're not going to implement that in our project, but yeah. So when you actually look at these files, you'll find hashes, and you'll find the actual source code for our Rust files if we're going to commit those, or whatever project we're working on. Yeah, and all these files have various different reasons to be here. They're pieces of the project, pieces of different adds and commits, and I'll talk more about that when we actually get into building that functionality. I think that's good enough for now. So let's go back into the project. And let's just start to build this thing. Apparently not a robot is 7. Well, I'm sorry about that. I'll try not to curse anymore. I know you're joking, by the way, but, you know, who knows? Maybe you are actually 7. That'd be cool, a 7-year-old learning the program. You'd be a pretty intelligent guy when you grow up. Or at the very least, you'd be good with computers. Probably not good with people, though. All right. So, oh yes, right. Almost forgot. We do have some dependencies we're bringing in here. So we're making a command line tool, so we want the clap dependency. Clap allows us to parse command line arguments and different commands. We're going to bring in Rust crypto because we need SHA-1. And that's how we make the hashes that you saw before. So just need some hashing algorithms, and this is a good library for that. We're bringing in this regex library. Regex is just, of course, pretty self-explanatory, just regular expressions. We're going to use them to search out different parts of our directory. And then lazy static. Lazy static is pretty cool. It allows us to define static variables and have them be lazy in the runtime. So lazy in that they don't get evaluated until they have to be. So this is mainly important for large things like trees and vectors and large collections of data where you don't necessarily need all of the data at once. And yeah, I highly recommend you guys take a look at lazy static if you work with Rust at all. All right, so there we go with that. And actually, guys, I hate to do this, but I'm getting a phone call that I have to take. Give me about 30 seconds to a minute, and I'll be right back. Alright guys, sorry about that. Had a colleague who was curious about something. Had to make sure everything was alright. Okay. So let's get into this. Before we really start to implement anything, let's build out some errors, because we're going to need some errors to report back to us if anything goes wrong. So I'll create a module here called error.rs. Let's add it as a submodule. And inside of error, let's create a enum. And we'll call it tgit error, because that's the name of our program, is tgit, as in tensor git. But really, it doesn't matter what the name is. And then what we're going to be looking for are IO errors. And this will have the standard IO error type inside of it. We're also going to be looking for errors where we can't find the directory, so no directory. We're also going to be looking for an invalid commit error, and then a invalid index error. The IO errors are obviously just errors that we get back from running standard, standard file stuff. So if we want to manipulate our directory, make files, open files, read files, all that stuff, we could potentially get back IO errors, and we want to handle those, so we want to put them inside of here. And then the rest of our errors will be these other errors here. And yeah, and if these happen, we can do various things with them. So we can just throw back a standard error piece, and then we don't have to write unwrap after every single line that may potentially cause one of these errors. All right, so let me actually make this easier by importing some of this stuff. So let's import standard IO, and then I can just call this as IO error instead. And then we're also going to need probably standard FMT. And we want to implement the FMT display trait for our errors so that we can actually display the error messages. And this, of course, involves implementing the FMT method, which takes in a reference to self, and then the formatter, which is just a reference to a mutable FMT formatter type. And then this returns back a result, and in our case, just be a result of a union type and then an FMT error. Maybe I should, let's see, probably decrease the size of this so you can see this a little better. All right, so we're just going to match on self, and we'll implement each of these cases. So if we get back a tgets IO error, then we want to take a reference of the stuff that's inside, and we'll just call this E. And we'll just say e.fmt, and then we'll pass in our formatter so that it will actually print out to the command line. Then let's see, for the no directory error, let's see, we're going to call formatter dot write str. We just want to say no directory found. And we're really just writing these out to the console. The formatter is just a basically going to work on the console. This could work on any other thing, like if we made like a graphical user interface, we could also make it implement with that as well. Okay, let's see. We need to implement these other ones. So invalid commit, and let me get the other one while I'm at it. Invalid index. And for both of these, we're also going to use the formatter write string call. For the invalid commit, we'll just say a commit is invalid, or the commit is invalid, rather. And then for the index, we can just say the index is corrupt. All right. Let's see. We also want to implement the from trait with IO error in it for our tget error. And for this, we're just going to add a from function, or from method rather, which takes, or takes in our error and will give us back a tget error. So we can convert a normal IO error into a tget error, and we can just use this from trait to do that. So we just say tget error, IO error, and then we just pass in our error here. Alright, so that's pretty self-explanatory, I would think. Hopefully this, I don't know why I'm still getting an error, but it should go away. Let's see, what's the error? This is very annoying. Missing from implementation, because I spelt this wrong. Sorry about that. Gotta love having dyslexia. Alright, well, that's pretty self-explanatory. Yeah, I'm not going to use get2 because I wanted to actually implement this stuff myself. Get2 would give me a lot of the features that we're building out here, and I feel like it would just be better to build them ourselves. But yeah, I know it exists. It's a very good library if you want to interact with Git and version controlling in general. Alright, so we've got our error, and with our error we can now go ahead and create the init command for our application. So let's go ahead and make an init.rs file. And you should be good with this, I think. I don't think we need anything else for init. Init is just setting up. So init, all we do with init is set up our directories and the various files and stuff inside of those directories. So in here, let me first wire this up. And inside of init here, we just want to, well, pull in our errors. And then we're going to need, and this should be super. Is it super? Yeah, super. Okay. We're going to need standard fs. And we're also going to need standard fs file, because we're going to be reading and writing to files. Going to need to use standard IO write, speaking of writing files. And then actually we're not going to be reading files, we're going to be writing files, but we need a symbolic file and we need to be able to write to it. We need to be able to get the path, so we need standard path, and I think that should be it for now. And for init, we're just going to create a function here called init, takes in nothing, passes back a result with our tget error inside of it as the error, and then a union type as the actual return type. And then we can say let der get our path new, and for our application we'll store everything inside of a folder. Let's just call it tget for simplicity. And then we can go ahead and use fs to call create dir to create another dir, and we want to create the directory for the one that we just created here, the .tget file. And notice I'm putting the question mark here, so if this comes back with an error, it will automatically throw back a tget error. So this would be an IO error, and if the IO error comes back, it'll call the from method that we created before, and then it will wrap that inside of a tget error and then pass it back to the screen. So we also want to create a directory inside of our .tgit directory. So we'll call this dir join. This will be our objects directory. No two T's. And again, we'll have a question mark. And we'll repeat this for our refs directory. And then for the head directory inside of refs. So refs, and then .join, and then heads is the name of this directory. So now we have the directory structure. We need to add the main head file and actually write the initial data into it. So let's make this, we'll call it immutable head. We'll use our file create to create it. And this will be in path dir join, and we'll just call the file with a capital head like that. And then we just want to say head writes all to actually write a string in here. And we're going to write it just like we saw in the actual Git implementation. Just going to be git refs heads master, like this. And we need to convert this to bytes, I think. Yeah. And again, we'll use our question mark, and then we'll pass back an OK with a union in it. And that should, yeah, it looks like it works. And to test this, I could actually come in here and just call it directly. So init, like that. We can go ahead and run this. Let me flip over to that screen. All right, so should run, should compile and run. Let's see. When we actually get more commands, we'll add in the actual command line interface. But for now, I just want to run this to see if it works. See if it actually builds out the structure that we want. And let's see. And it looks like it did work. Let me bring you back over to the editor. You can see here we now have this tgit file, or folder rather, with an objects folder inside of it, a refs folder inside of it, and then inside of that we've got our heads folder. And then inside of this head file we have our string that just says refs head master. Perfect. So that works, and works is exactly as we expect it to. So that's actually the easy part. We've got all the folders set up and everything. Now we need to be able to interact with them in a way that's, well, like Git. And of course Git uses various different abstractions. So let's talk about those first to kind of get you guys to sort of understand what we're going to be doing here. So let's see. We're not going to be doing anything with objects, I don't think. All right, well, first let's talk about blobs. So blobs are very simple. Okay, let's talk about objects. So in Git, you've got these generic objects, and objects have various different types. When you commit files back to Git, you create various different objects, and then these objects are stored in what is essentially a key value store and sort of like a tree at the same time. So we've got this like tree shape, and then inside of it is this sort of, I guess, key value store where you're hashing the data, and then you're using that hash as sort of the key for the data itself. And the tree itself is a work tree, and then you've got the actual Git directory. So these are the two main things that make up a repository when we are talking about Git. Then inside of this tree and inside of this directory, we have our objects. And one of the main object types, the one that we're going to be working with at least, is this blob type. The blob type is sort of like a non-specified type that just can really have anything inside of it. And that's what makes it very easy to manipulate, because you can just kind of like throw a bunch of data inside of a blob, and then you can use that blob to serialize and deserialize back and forth from the files that you want to write and stash and so on. All right, so we need to implement the logic for this type of, well, first we need to implement the logic for like the tree, and then we want to implement the actual blob itself. So let me go ahead and we'll create a file here and call this types.rs. And of course, we want this to be a submodule. Inside of types, let's make a enum for the tree first. So the enum just be called tree. Inside of it, we can have blob and tree. And the blob will have a name, which will be a string, and then the hash, which will also be a string. Then we'll also have a tree entry, where we have a name string, and then a hash string, and then we want to have the children of this tree, which will just recursively call the tree inside of a vector. And I think that should be about right. Now, let's see. Thinking we should probably implement the index. I'm not really sure how I want to go about doing this. Sorry guys, I'm having a bit of a brain fart moment. I know what I want to implement, but I'm not sure how I want to go about doing it. Let's see. All right, well, let's set up the blob while we're at it. So all of our blobs just be a public hash string, and then the data, which will be a vector of U8, which will be just our data as bytes, essentially. And maybe we don't actually want to put all these types in here, but you know what, that's fine. Then I guess let's define a commit. And no, we'll do the commits after. Let's define the index now. I think that's how I want to do it, yeah. All right, let's define the index. So the index, no, don't want to do that in here. Sorry about that. All right, so we've got our tree, we've got our blobs, and we want to implement some methods for the blobs. Make all this work properly. Keep getting text messages. Sorry, guys. All right, so let's create an implementation block for blob. And we want to create some data that will allow us to get these blobs from the directory. So we're going to need some imports here. Let me get them. We're going to need standard IO, standard IO read. Going to need standard fs file again. We're going to need standard path buff. And I think we'll probably need our crypto stuff, so crypto SHA-1. Is it SHA-1? And then I think we need a digest. Digest like that. Yeah, all right. And okay, so those work like that. So this is our third-party library here, this crypto stuff. This will allow us to essentially hash everything in the way that we want to. So, all right. So Blob will create a function here, or a method rather, called from_path, and we take in the path, which is just a path buff type, which is just the if you look here, it's essentially just the path, essentially with a string inside of it and some metadata. So the path that we're referencing inside of our directory. All right, so then this function here is going to return back an IO result type, and inside of it we'll have the blob. So we want to create a file first, so file open on our path. Then we can say get the bytes for the file, so let's first create a vector for that, and then we can say file.read to end to read the entire file, and then we'll put our bytes in here or we'll put it into our bytes vector. Then we can take this and call SHA-1 new to create a SHA hash, and then SHA inputs our bytes in here, so we want to hash the bytes, and then we can pass back a blob inside of OK, where the hash is our SHA, and I think it's result string, yeah, and then the data is our bytes. Let's see, should go away. There we go. All right, so we read from the from our various files in here, and then we convert all that data into bytes, and then we create our blob object from that. So it's actually fairly simple if you think about it. Alrighty, so now excuse me. Now I think we want to implement the commit structure. Or no, before that we want to implement the index. So let's create a new submodule here called index. And the index itself, the index is sort of like a staging area. So when you add data using like git add, the data goes into this index and it doesn't get pushed into the repository, at least not officially into the repository, until you actually type in commit or something like that. So the index itself is the staging tree, so it's just a tree with a, well, we'll have a path here, which will be a path buffer, and I need to import that. And then we'll have the hash tree, which will be a btree_map type, which is a type inside of Rust that we can import with strings in it. And standard IO. Get that btree_map. I'm going to need buff read, buff reader, and we're going to need write, like that. Probably need fs file, and of course we'll need our path buff. There we go. So this is what the index looks like. And now we can implement stuff for our index. So let's first create a method to create a new one. So we pass in the root directory, which will be our path buff, or a path buff rather. And then the result here will be an index with a tgit error, and I need to import that. Super error. There we go. So let mutable index equal index. The path is just the root directory. We join it with our .tgit folder. Then we're going to join that with the index folder, or the index file rather, like this. And then the hash tree is just a new B tree map. Then we can check if index path exists. Return OK with our index in it. So if the path already exists, we just return it. Otherwise, we want to essentially build the path. So we'll say let file equal buff reader new file open, and we're going to open this at our index path. Put a little error handler there. Then we can say we're iterating through these files, so we want to say for line in line file.lines like this. And we're essentially, we want to take each of our lines and convert them into our blob type. Okay. Yeah, and add them to our blob, which will just be a huge vector. So we say let's just call this ln equal line, and then we'll say blob, which is just a vector slice of string type, equals ln.split. Put these at any white space, and then we'll collect them. And then we want to check to see our blob length. It's not equal to 2. We'll return an error. And this will be our tgit error invalid index. I think that's what we called it. Yeah, invalid index. So that's our error type there. And then if it is longer, or if it's not equal to 2 rather, we can update our index by passing in blob 1 and then blob 0. And update is a method that we need to implement here. And then we'll pass back OK with index inside of it, like that. Let's see, guys. So, are you guys understanding this, or am I kind of breezing by a lot of explanations? If you guys have any questions, you can obviously ask them. So here's what our update function will look like. Pass in our index, the self. Then we want to take in the path, which is the first blob, or rather the second blob. And then we want to take in the hash. We just want to insert them directly into our hashes index, or our hashes vector. Let's see. Let's also make a print function so that we can actually see this thing. So take self. We'll just say for ref hash ref path in self.hashes.iter and print ln. Put in our hash and then our path like that. John says that he understands this better than other langs. Well, that's great. What I meant is not the Rust itself, the what we're actually implementing here. I feel like I've kind of muddled the explanation. All right, we need to also be able to write on our index. And this method will take in the index itself, and then it will pass back a IO result with just a union type inside of it. Create our file by getting self.path. So we're essentially just getting the file again, and then we can iterate through it again, and I can actually reuse this code here. So I can say ref hash this seems about right. We just don't want the print ln. Instead we want a write ln, and for this we need to pass in mutable index because we're writing to that, and then we're going to write our path and hash into the index like this. And the index is of course the file that we opened, and then just pass back our union type here. And then finally we want to be able to clear the index, so clear, so take in mutable self, which is the index itself, and then IO result. We'll say self hashes, and it's hash tree. I keep saying hashes. This should all be hash tree. All right, so self.hash tree equals b tree map new. So we just clear it by recreating the tree, or creating a new tree, and then we can just call self.write to execute this function to repopulate the tree. All right, and I think that seems about right. Let me look through this real quick again, see that I didn't have any issues. What's with this? Oh, missing a semicolon, or a colon rather. See, I don't think there are any errors. There might be a few here. This should be capitalized. And yeah, that looks about right, but we'll see when we run it. But I don't think we'll run it for a little while. All right, so we've got the index, we've got the blob type, we've got the tree type, we've got our init command already set up, and we've got our errors. Now let's we need some way of interfacing with the directory, so for both commit and add. So let's create sort of like file service command, or not command, but structure. So create a module here called file.rs. Of course, that deleted module, didn't it? Hate that. I wish they would fix it already. Let's see. Yeah, I think this should be all right. All right, so in here, we're going to need a few things. Standard env, standard fs, standard fs file again. I'm going to need to use standard IO. Use standard IO read write. Use standard path. And we're going to need our path buff. And then the path again. And then we're going to need a few imports from our own stuff. So super, let's see, the types. I'm going to need the blob type. Super errors to get error. And I think that should be all right. And it's not errors, it's just error. We may need to create the commit object first, but let me just define this structure. So we'll call this file service. Put in our root directory, path buff, then the tgit directory. Again, another path buff, and then the object directory. Again, another path buff. So root directory is the root of the project. The tgit directory is just this tgit directory, and then the object directory is obviously our objects directory here. All right, so let's implement some stuff for file service. Want to create a new one, and we still want to use our errors. Tget error, like that. Let's define root directory, which will just be file service. We'll have a function which we're going to call find root, or rather a method which we'll call find root. Then we'll have our tgit dir. What am I doing? Which will be off of the root directory. Join this with .tgit, and then to path buff. And actually, you know, while we're doing this, let me just create this real quick. Let's make this not public. And we'll have this will pass back a path buff, and then it'll also have our tgit error in it. And so this is just to get our working environment. So we'll just say mute current directory equals env current dir, like that. Use our question mark because if we have an error, we can throw it back. And we want to loop around. Do we? No. For now, let's just pass this back inside of OK. So we'll say OK current dir. Later we'll add a loop so that we can check to see whether or not we're inside of the tgit directory or not. And if we are, then we can address that. So now we can actually get the root directory, and then that will inform the rest of this. So let's get our object directory. Again, we're going to call to our root directory and actually in this case, we can just call to tget directory. We'll join this with objects. Then again, we'll call to path buffed. And then we'll pass back an OK with file service inside of it. And we can just say root dir, tget dir, and then object dir, like that, to put all of these variables in it. You know, actually, while I'm thinking about it, let's create the function to determine whether or not we're inside of our tget file. So let's just call this is tget. And this is going to need a generic, generic p for path. And we're going to pass back a boolean. We're going to need a guard here, so where p is a sized, or has a sized trait and as ref trait implemented on it, and it's wrapping around path. So now we can just say path as ref join dot tget, and we can just check to see if this exists, and that will give us back our boolean. So now that we have that, we can come back up here, add our loop to loop around. We can just say if file service, and then we can just call is tget, pass in our current directory, or a reference to current directory, and then for if it is, then we just return this, and then we can just say if current directory pop return error, or the error part, and then we put in our tget error, and what did we call that thing? No directory. That's the one we want. That's the error we'll create for this, and then that will crash out. Well, at least it'll give us the error. Alrighty, that looks better. Now, let's see. Okay, so the main reason why we want this file service is to be able to get the head reference and then get the hash from the head reference, so that we can also write our blobs and then do our commits and stuff. So let's create some more functions here. Call this get head ref. And this will pass back a result with the path buff in it. Get our head file by calling file open self.root directory join, and we're looking for our tget \capital head file. And we need to get our reference path. And first, this will just be a string new. And so we take the head file. I'm going to read it into that string we just created. So mutable ref path. Alrighty. Then let's see. We also want to go ahead and take the ref path, and it probably needs to be mutable, reassign it by splitting off the sixth index. I'll show you this part here. We want to split this off so that we can connect this and actually create a path. So like for instance, if the path was like dot tget like this, well actually on Windows it'd be like this, then it would be refs head master, something like that. Yeah, refs heads master, and it should be heads like that. So if we're going to put it in like this, then it would be refs like this, and this would throw back an error because this is not a directory, obviously. So we need to split off this part of the string before we create the directory. So then we can just say, okay, self.tgetdir join, and we join that directory with the one that we just created, which is the ref path. And yeah, this actually doesn't need to be mutable. What's with this? Apparently this is never used, even though I used it up here. And whatever. Must be an error. Alrighty, so another function we're going to need is write blob. Get our blob type. So this will help us create our blobs. We just say self write. We'll have a function or a method called write object. And this will just take in the hash and then the path, and then we can just, or the hash and then the data, and then we can just put that into our blob. So just say blob.hash and then blob.data, like that. And let's actually go ahead and create this. So, and actually, all right, let's add this real quick. The data was a vector of U8, I think, yeah. All right, so we'll say let blob dir equals self.object dir dot join. We want to get the hash, the first two characters of the hash, because that's the actual directory of the blob inside of here. So as we're adding blobs to our objects folder, they'll be referenced by the first two characters of the hash. You saw that in the Git folders. Each of the folders had first two characters of the hash that, well, they were made up of two characters, but that was actually what it was. It was the first two characters of the hash that references each of the objects. So that's essentially, this is the logic that is being used. So blob dir, we need to make sure it exists or not. If it doesn't exist first, rather, we can call fs create dir to create it. And it doesn't matter if we don't populate it with anything. Then we can just say blob file name, which will just be blob dir. Let's join this. Oopsies. We'll join this with the rest of the hash, so from index 2 on to the end of the hash. So the file will be called, you know, the directory will be called the hash, the first two characters in the hash, and then the file itself will be called the rest of the hash. And then we want to write into the file, so let's put in our blob file name that, and then blob f write all, pass in the data, and then pass back OK with the union in it. There we go. So that'll write the object. Let's see. So now I'm looking at questions. Tom wants to ask some questions about Flutter. You want to know how to launch a local host and access it through a web view. You should be able to just use the loopback, the normal Android loopback, which I think is 10. What is it? Let me look it up real quick. It's 10.0.22. So when you're connecting to any kind of local host, so you have like a server on like 8080, you would connect to it like that instead of localhost 8080. That's if you're using AVD. If you're using like AnyMotion, I think it's just 10.0.3.2 instead of 0.2.2. Anyway, I think that should help you. I used that in the other example, the Rust example that was like a chat app where we made the front end in Flutter. So yeah, you can go take a look at that. Yeah, it lets you access the local host that's on your desktop, and then access it from the Flutter front end if it's on an emulator. If you're on a device, I'm not sure how that would work, but if you're on the emulator, that the command I just showed you should work. Oh yes, if you're on a device, then you get your the actual IP address that you'd find for your computer on the network, and then you can connect through that. It's a bit of a pain to do, but you can do it that way if you want to as well. Yeah, you should be able to get from the app and access the app itself. So you're accessing the app from, all right, so if the app is a server and you're accessing it from Android, you can access it through that loopback IP address. If you want to access your application through the emulator, I'm not sure. I think that should be all right. There's a whole thing on it. Let me see. Let me get you the page. You can take a look at it. There you go. Just follow that link and read about it. It should help you with whatever questions you have. If anybody has any other questions, they can be off topic too. You can go ahead and ask them while we're doing this, and I'll be sure to answer them. Alrighty, so I think we're missing a few things here, but for now this seems about right. Let's see. All right, so what do we have? Let me kind of get back into the headspace I was in. Now I think we should be able to create the add command. So let's do that. So just call this add rs. I think we have enough to do that. So mod add. And of course that stupid thing keeps trying to alphabetize all the imports and then it ends up destroying some. Anyway, so we're going to use standard env. Use the file service. What do we just call it? File, right? So it'd be super file file service, use types blob, and that's a capital B, use our index type, and then we can also use the error, of course, and these should be super. I think they have to be super anyway. To get error like that, it should be all right. All right, so this is just one function. It's like our init command in that it's just one function. We have all the abstraction that we need. So let's see. Let's just call this add data. This would be a vector of U8 or a vector of str rather. Turn back a result with a union in it and a tget error on the error side. And then let's see. Actually, I'm just curious if I can just remove this super keyword. No, okay. That's what I thought. Alright, so to instantiate a file service by calling file service new, then we can say let current directory, let's just current directory env current dir like that. We could unwrap it. I think we can just use our error handling like that. Create our new index. Call the file service, get our root directory. I think that's what we called it. Yeah, root directory. All right, so now we want to go and loop through our add data, and this will have all the files that we're adding to our index essentially. So we'll say let full path equal current directory join, and then we'll add the file to it. So that's the actual file name. Then we'll say let blob equals blob from path. Do we have this function yet, or this method? We'll path, put that in there. Let me see. Yeah, we have from path. All right. Then file service. We have the right blob function, which we can call. Put in our blob. Then relative path. That's what we need. Get our full path. Call strip prefix. And this we can call file service.root root directory. And then we can call unwrap like that. And then index.update relative path to string unwrap. And then we also want to pass in our blob hash. And I think it's blob hash tree actually. No, it's the blob hash. It's the tree hash tree. Okay. All right. Alrighty, and then outside of this for loop, we can say index right, and then OK, like that. Let me make sure we have that right function. Yeah, we do have the right method in there. And that should, there we go, that actually solves everything. All right, so this will actually work. This will allow us to add files to the back here. So let's see. Let me call it, see if it'll work. So add all. And then we want to put the data. So let's see. How would we call this? Okay. Just need to get the data, read it in to a vector. Okay. Let's see. You know, we probably should set up clap, and actually that's what I'm going to do. So let's set up clap in here. That way we can have both our init and our add commands working. So clap app arg and subcommand, and then we can say let m equal app new, call our app tget, and then let's add our subcommands. So first one will be subcommand with name. This will be for init. So when you type init as a subcommand to running this executable, it will then execute some stuff, and we can even say initialize the repo. And then let's add another subcommand. I like clap because it allows you to kind of chain all the commands together like this. So let's say subcommand, and you can even you can see here it says from YAML. So you can use a YAML file to define all of your commands if you want to. I'm just using strings because it's easier this way. So we'll also have the add command. Oops. And then add also has an about, add a file, and then we can also have the argument for add, which is just this arg type here. So rather than a subcommand, this is an arg. So arg with name. The arg will just be called file. And then we could add a help to it. Let me make this readable. So help, just gonna, if we do call help, it'll just say file to add. And then, let's see, the index of this argument will be 1. And then we can have multiple of them. So this will allow us to add multiple files. And then we can also have them be required. True, like that. Let's see, will this reformat in a way that actually looks nice? You know what, I'll just do it myself. Gotta say, I wish they would speed up the RLS server. It's a kind of pain in the butt that it's so slow, and that sometimes the formatter doesn't kick in until the worst opportune times, or the least opportune times. Alright, and actually, let's bring this down and push these over. That looks better. Alright, so we're not done here though. Actually, we are done here. We don't need to add the commit subcommand yet because we don't have it. So now we can match on m subcommand and it's just subcommand. So now we match on each of the subcommands, and if we get back init, then we'll get back sum. We don't care what's inside of it. And then we can just match on, let's see. The init command that we have, so init, like this. And if we get back OK, we can print out repo initialized. Get back an error. Then we just print out already initialized, like that. Let's see. This should be closed like that, and this should be gone. All right. We're also going to need add, and inside of this we'll have a submatch, which will be the actual arguments, the file names that we're passing in, and we can match on them. So our match on the add all call, which is an add, so add all like this. And then we can just say submatch dot value of file unwrap collect. That'll give us a vector of all the different files, and then we can just say okay. Don't really care about the return here. Not going to print anything out or anything like that. If we get an error, then we want to handle that error, so we'll just print that out. Oops. I don't even know what that is. So error, and then we just pass in E like that. And let's see. Oh yes, we need the final pattern, which is just an empty pattern command not recognized. Did I spell that right? Yeah, I did. Let's see. Whoops, I didn't mean to do that. What's the matter? What is it looking for? Maybe it doesn't want a tuple? That's very strange. Okay. Let me go look at the clap documentation, because I feel like it's changed recently. And it's been a little while since I've used it personally. This is how I used to use it. So let's take a look. Gotta fire up Mozilla for this, so you guys can take a look. Alright, so Chester, the difference between super and crate. Super is when you're calling from a submodule. And then crate, I mean, I don't think there is a difference anymore. There used to be. I recommend looking at the 2018 Rust module changes, because they've really changed a lot of things. Like, you don't have to externally import libraries anymore, which is why you never saw me import like clap or anything like that. Hang on. Let me bring up the browser here. So yeah, you never saw me import any of that stuff because didn't really need to. So yeah, there are a lot of new pieces to it. All right, so here we go. Here's an example. So matches, then matches occurrences of. No, that's not what I want. Subcommand matches. That's not what I want either. Oh, okay. So there's like this new macro version, which is kind of cool. And not that I actually want to use it. um, let's see. All right, so this version, they've got a subcommand of test. All right, so they're just saying if we get subcommand test, then we want to check to see if debug is present, and then it's print it out. That seems pretty annoying compared to the old way of doing things. Let me see if I can find a good example. Let's see, do they have something better than this? This is not a good example. I want something that shows like multiple different command line arguments. Let's see, where's a GitHub repository? I think I can just... No, I don't want to go to Travis. Let me just look it up. Clap. Again, only one subcommand. That's really annoying. Alright, here we go. Subcommands. So we've got two of them here. Subcommand name. I guess that's what I want. No, see, they're using tuples too. That's really confusing. Alright, well, arg matches subcommand. So I guess the M that I'm getting back is an app, not an arg match. That's strange. Oh, it's because I didn't call get matches at the end. This thing here. Yeah, once I did that, it fixed it. All right, let me come back into the editor. So you can see here, I had to call this, and then that fixed everything. Let's see if I can fix this part now. So let's see, value of file, unwrap, collect. Why is it not letting me collect them all? Shouldn't be coming in as a string. Let's see. All right, so arg with file, help to multiple required. I mean, it should be coming as a slice of string, but should be able to collect them. Exists, but the following traits were not satisfied. Okay, so it's telling me that there's no iterator apparently, which is kind of silly. Let's try again. Let's try it without the reference. So submatch values of. Oh, maybe it's values of as opposed to value of. If it's that, I'm going to be really kind of angry. Let's see, file, unwrap, and then collect. It's literally an S. No, okay. So what's this saying? There we go. Iterators over elements of vector. Okay, so what about if I make it a reference again? Yeah, so it was literally just S. That's really annoying. That pisses me off actually significantly. All right, well, whatever. You know, I mean, I guess this happens. One of the things I really dislike about Rust is that the APIs are always changing very drastically, especially if you're working on the nightly branch. And yeah, that can be really, really significantly annoying. Java programmer asks if we're implementing a Git tool. We're implementing Git essentially in Rust. John says, I believe super allows children to call up to the file tree. Yes, it allows submodules to call other submodules. So by calling super, you can call to the top module and then call as though you're at the top module. Crate, I think, also does the same thing, though. I mean, that's the thing. Like if I come in here, let's say I go into add and just replace this with crate, should still work perfectly fine. That's why I'm saying I don't really think there's much of a difference. I mean, aside from this nonsense. Alright. You know, the best way to deal with this is just to add spaces, then it doesn't try to destructively delete things to organize them by alphabet. So anyway, yeah, see, I can just call crate like this, and I can also call super, and it's literally the same thing right now. So I don't know why I chose to use super in this case. Last time I used crate, this time I'm using super. It's not very consistent. I wish they would make it more consistent. Well, hopefully in the future that will happen. Okay, so let's go over to the command line and take a look at our new add command. And I don't even know how long we've been streaming thus far. Looks like almost an hour and a half. So maybe we have time to put in commit. I think we just barely do. I didn't really want to go for 2 hours, but I guess we can do that. All right, so transition over to the command line. And I can just run cargo run, and let's just add our main.rs file. And if we wanted to add more files, because we're on Windows, we don't have a direct batch command, so I can't just like write source star.rs. If you're on Linux, you could do this, and then it would just take everything inside of the source directory and call add with it. So instead, I have to like add each file independently, which is really annoying. So if I wanted to add all the files to Git like this, I could do it. Anyway, I'll put 3 of them in there. It looks like it came back without an error. So then if we transition back, you can see here now inside of our objects folder, we have these 3 different folders. Each of them are named after the first 2 characters in the hash for the data. And if we look inside of them, you can see they actually have our files in them because we're not actually encrypting the data like Git does. Instead, we're just pushing the data back here. But each one is, of course, has its own hash name and everything. And let's see. And then also inside of index, you can see it actually is saying, okay, this hash is associated with this file. This hash is associated with this file, and so on. All right, I don't want to save any of that. All right, so let's add commit while we're at it. So for commit, let's make a new file. Mod commit. All right, commit is going to be a little bit more complicated than add or than init because it requires its own special type. So with commit, we're going to need to, and we're also going to probably need to modify our file service again. So let's create the structure for commit. Each commit is going to have a hash, which will be an option of string. It's also going to have the data, which will be an option of vector U8 type, so a vector of bytes. Then the parent, so the parent to the commit. You got to remember all this is in a tree structure, so this will be an option of string type, and then we'll have the files, which is our big old tree, which is that B tree map type that we were using with strings inside of it. And so of course we need to make those imports. For this we're going to need our regex library, which we haven't used thus far. So let's bring in our B tree map, not B tree set, B tree map, IO write, super crypto SHA-1. Actually, do we need to write super for third-party libraries? I don't think so. But we're going to need our SHA stuff. We're also going to need the digest. We're going to need the regex stuff too. It's just a regex type. And then we'll need our error. And we'll need our index. And I think that's it for now. All right, so let's now implement methods for commit. And of course, these are either create or super, it doesn't matter. As you can see, it doesn't really matter. I'll just make it consistent, use super for both. So first we need to create a new function, or a new method rather. New is going to take in the parent. This is the parent commit, so option of a reference to a commit, and then it will pass back the commit. And we'll say let commit equal commit. The hash for this will be none. The data will be none. The parent will be match parent. And we just want to check to see if the parent exists or not. Obviously, when you first initialize your tree, you're not going to have any commits. So, or your repository rather, you're not going to have any commits. So, I just want to check to see if the commit has a hash in it. We'll reference this with hash. And then the rest of it we don't care about right now. So, if it does have a commit in it, and I am using parentheses, not brackets, then we can say sum hash to string and pass that back. And then if we get back nothing, then we want to pass back none. And then for files, we'll make a new B tree map. Put that in here. Oops. Alrighty. So let's see. That looks about right. All right, so now we have our commit. We can use a for loop. We'll reference the hash and then the path again. And we're iterating through our parent as a flat map. We're going to need to use a closure here. And the P stands for parent. And we'll just say p.files.iter. Let's see. I think I probably want to write it like this. Yeah. So, like that. Excuse me. All right. So now we can say commit files insert hash to string, and then path to string. And insert is, well, this should work. Let's see. We're just inserting this into our B tree map, and then down here, pass back the commit. All right, let's see why this is throwing an error. Oh, no, of course the error goes away because the RLS is really, really slow. All right, we're going to need a from string function, or method rather. So pass in the hash and the input. Both of them will be slices of strings, and then this will pass back a result with a commit and then a tget error so that we can handle the errors. And yeah, we should create our new commit using our commit new method that we just created. And we'll pass in none so that it will be empty by default. And then we'll say commit.hash equals some hash to string, like that. And then we'll use lazy static to define some static references. So static referent parent is what we'll call it. This will be a regex. We'll create our new regex, and we can use the string literal regex type for Rust here. So parent, and the regex itself is just 0 to 9, A to F, and then I think these are size 40. That's what the SHA strings are. All right, so we're looking specifically for anything that matches this pattern, and I think we need a space here. And then we'll have a static ref for blob, which again is another regex. That's really annoying that it won't give me double quotes like that. Anyway, same deal here, 0 to 9, A to F. Oh, this is annoying. All right, there we go. A to F like that, and of course 40 characters. And for this one though, we're also looking for a dot at the end. Like that. Unwrap that. Let's see. Let me zoom out a little bit so you guys can actually see this. Alright, so apparently lazy static's not in the scope. I guess I have to go specifically import the crate. And that's very odd. I shouldn't have to do that. And add the macro use flag. And actually, I'm going to go ahead and take this, put it inside of main. I shouldn't have to do this at all, but apparently I do. Alright, so that should clear it up. Alright, so we have our two regex patterns. Good, good. Now we want to go through each of the lines in the input files, so, or the input strings rather. We'll grab the captures using our parent. I can't spell capture. It should be captures. Pass in the line. Then we'll say commit parent equals sum caps.get1 unwrap as str to string, like that. It's a bit of a convoluted line of code, but whatever. So we're matching for the parent, and then we also need to match for the caps of the blob. So for the cap of the blob, we'll get the first capture for the hash, or the first capture will be the hash rather. Then the path is the second capture. And then commit files insert hash to string, and then path to string, like that. And then we can just go ahead and pass back OK with commit inside of it. Like that. Now, why are we getting errors here? Okay, errors are gone. I don't know. Alright. Alright, so we're good to go there. I'm sort of rushing here. It doesn't seem like any of you guys have questions, but I'm sure you do have questions, because I'm sure this is extremely confusing, but whatever. I'm going to write the code now, and then I'll go back through it and kind of explain it after I'm done. Alright, so next we're going to need a print function so that we can print all this out, print out the commit itself. So if let sum ref p equal self.parent println parent p, and then we'll go for ref hash ref path in self.files.iter, iterate through our files, and then we can print out the blobs in here. Blob, like that. Put in the hash and then the path. Alright, that's good for print. Now we need to update a commit. Because commits are mutable, we need to be able to update them. So create a new vector. So this is going to get sloppy, guys. I'm sorry about that, because I kind of wanted to get this done, but we didn't really get as far as I would have liked. I didn't really expect it to be this long, actually. That's why. Whatever. Let me go real quick. You're gonna need another right line. Let's grab this. God, that formatting sucks. This is for the blob part. Grab this. We need the hash and path. Okay. Then after we iterate through the parents and then the blobs, we'll go ahead and create a new SHA. Push in the data to hash it, and then self.hash equals some SHA result, result string, and then self.data equals some data. All right, that looks right to me, but who knows? I probably made multiple errors. All right, so now let's actually make the commit command. So all of this is just in service of making commit work. Okay. Let me go back through this real quick. Make sure I'm not going crazy. All right, so what's going on here? Type regex not found in the scope. I thought I had imported it. I guess it got deleted, probably. Actually, I can guarantee it got deleted. They really need to fix that. It is the most annoying thing in the world to have your imports just randomly delete themselves. Okay. All right, so let's create the and actually before we create the commit, gonna need to go back into the file and import or implement a few more functions in here. So, and actually let's import super commit. That is the most annoying thing in the world. I knew it was going to happen. All right. So let's see. What do we need? I think we're going to need a write object, or a read object rather, not a write object. So let's see. We've got something to get the head, something to write the blob. We need something to read the commit and write the commit. And we'll need something to read the object. So these are actually fairly straightforward. Read commit is just taking in self and the hash, then outputting a result of commit to get error. And this just calls commit from string hash self.read object hash question mark. Let's see. From string should return a commit and a tget error, so this should be all right. Now, all right, we don't have read object implemented yet. Kind of thought we did because I figured well, okay, so we need to implement that now. So read object is like the reverse of our write object function. So take in the self, take in the hash, which is again a slice of string, pass back an IO result with a string in it. Let mutable data equals string new. Create a new string so that we can read it from the files. And then we need to use our random or our file store to get the directories. So object file name equals self.object dir.join. Again, remember the paths in here are all the hashes. So hash double dot 2, the file name, and then or is the directory rather. Then we need to get the file name. So hash double dot or 2 double dot in this case. So directory is 2 characters, first 2 characters of the hash, and then the file name is the last 2 characters of the hash. Then we can say object file equals file open. We're going to open this object file name. Then object file read toString is what we're going to need. We're going to read this into our data as a mutable value, or mutable reference rather, and then pass back the data. Alright, so that worked. Now let's implement write commit. So we did read commit, now write commit. So write commit, I'm going to take in self the commit, which will be a mutable commit because commits are mutable, IO results, and this is passing back that, the union type again, and then commit.update is what we'll call. Did we even implement that yet? I think we did, yeah, update. So we call commit update to update the commit, and we want to match on commit and mutable commit hash sum ref hash. So if we get a commit where we have some hash and some data, then we want that stuff. And we'll specifically call write object with the hash and the data in it. Then we'll call, we'll get the head. So self.get head ref is what we want to call for that. Then we can say let head file equal file create. Jesus, it's getting dark in here. One sec, guys. And then head file write all. And we're going to write our hash as bytes into the file. And then for the other case, it's just going to be a panic. Commit should have data and hash. And finally, do we need a comma there? No. Why is this throwing errors? Well, we'll find out. Anyway, pass back OK. Alright, let's see what's going on here. Oh, the errors are gone. Of course they are. But that's the error's not gone. Alright. It should be as bytes, not as byte. Alright. I think that's it. So now we can actually implement the commit command. Yay. So let's do that finally. Alright. So commit, this is going to use all the logic that we just created to commit stuff to our repository rather than just adding them. So things need to be added first and then they can be committed. So let's call this commit. And this function is going to return a result with potentially an error in it and a union type as the main one. So, and I'm not sure if I imported what we need. We do have error in here. We do need our file service. We have our index, and all right, so I think that's all we're gonna need. So down here, why is this throwing an error? Whatever. Did I type it in as tgrit? Of course I did. tgit. All right. Create our file service. Then get the head reference. Then we're going to say parent hash equals file service get hash from ref head ref let mutable index equals index new fs.root dir. We did implement this, didn't we? I know I've called it a few times. That's what we need. Get head ref. Why is it complaining? Downstruct path buff, but we need a path buff. Okay. Oh, calling the wrong thing. Yeah, that's right. Get head ref, get head ref. Did we forget to write the other one? Don't tell me we forgot to write the get the hash from the ref. We did. Okay. That's not too bad. So, alright, I'll just put this here. We need to be able to get the hash as well. So ref path, given the ref path that is. So we return an option of type string like this. And we can match on file open, of course capital file open, with our ref path in here. Get back an OK, ref mute f, let mute hash equals string new, then f.read to string, pass in our mutable hash, unwrap this, and then pass back some hash. For the error, don't care, just pass back none. That's all it is. So it's pretty basic, just a pattern match to unwrap all this stuff, put it in a new string. Alright. So, what did I even call that? Get hash from ref. Okay. There we go. So where was I with this? Where I derailed myself. Alright, so we've got the index, we've got the parent hash, we've got the head ref. We're going to need to now create the parent. So we take the parent hash, match on it, we get some ref back, and we take that and we just want to say read commits h. H is the head, of course, of the parent. Then if we get back none, then we'll pass back none. Then we can say let mutable commit equal commits new parent as ref, then parent.map p.print, so print out all the parents, then commit add from index, pass in our index, commit.print, print the commit, write commit, and I think this takes in the mutable commit, and then index clear, and then OK. Phew. I think that's it. Let's see if they concur. We may not have created this add from index to our commit type, which means we may have to go create that now. Okay. That's strange. I could have sworn we did. Guess not. Okay, well, that's not a huge deal. It's just a very thin wrapper function. So, function, add from index, immutable, self, index, takes in the index reference. Let me say for ref hash, ref path in index dot hash in our index, isn't it like hash tree iter self dot files dot insert hash to string, and then path dot to string. Phew. All right, I think we're done finally. So now it's just a matter of wiring the rest of this up to the command line interface, which we've already really set up. So it's just a matter of adding the command, which is pretty simple actually. And then we've got 3 working git commands. Which is actually something considering it's only taken us about an hour and 8 minutes. Alright, so let's finish that, and then I'll take whatever questions you guys have, and hopefully I've explained this well enough. I'm not sure I have though. Alright, so before I do that, let's add the commands here. So like we did with our other subcommands, just a matter of chaining everything together. So subcommand again, and subcommand with name commit, and this doesn't have a argument, it's just a subcommand. So commits a change is what we'll just say, and that's really it. We don't need to do anything else with it. Then down here we're looking for commits, and then I think it's just sum. Do we even need the sum? No. So sum, don't care what's in it. We'll match on what is it? Commit. Call our commit command. Then if we get back an OK with a union, we want to pass back that union. And if we get an error with an E in it, then we'll print out that error. And there we go. Finally. Unwrap is for when you want to unwrap a data type that is wrapped around something. So like for instance, an option type, you can either have some value or you can have none, and there's nothing inside of none. If you want to unwrap from an option type, then you call the unwrap method on it, and it allows you to automatically unwrap the inner value. The issue with calling unwrap, though, is that you're not actually dealing with any kind of errors or panics. Instead, you're just saying, all right, well, I'm going to assume that this will be some value, and it'll be the right value. And so usually when you're working in production, you won't actually call unwrap at all. And in fact, in a lot of the application, you'll see that I have these question marks. The question marks deal with the result type, which again is like the option type in that it can either have an OK value with some data inside of it, or an error value with some data inside of it. And with these question marks, we're basically saying, all right, unwrap it, except unwrap it with the logic of our tget error type that we set up in the very beginning of our application. So all of the calls that have the question marks here, they will handle the errors using the tget error handling that we set up. But if we call unwrap, then we have nothing to handle the error. So like here we're calling unwrap. That's simply because, well, I don't even know why I'm calling unwrap here. I should probably put a question mark, but I'm not even going to get into that. Alrighty, let's get back into our command line and run this thing. See if we can commit some stuff. So in this case, with add, we just added the files each individually. With commit, we can just call commit. Let's see. We get the system cannot find the path specified. So there is some kind of error in here that I'm going to have to look for. But let's see. Did we actually get a commit object to happen? No, we didn't. All right, so let me go through commit real quick. Fortunately, I don't have much time. All right. We make our new file service. Headref, da-da-da-da-da. It could be an error here where we call it the root directory. It should be fine, though. Recommit. Da-da-da-da-da. Well, actually, we could just see, like, I could just call println, put in a debug flag here, and just call fs root directory and see what that is. And according to this, it didn't even print out. So I'm thinking that the error is coming from our regular expressions. So let me take a look at those real quick. Potentially from our regular expressions. Could be something else. Let me think. I mean, these look fine to me. There's something about them that the format looks alright. The second one, I'm missing a parenthesis there. And I'm even missing a parenthesis for the first one too. That's not good. Alright, well, we're still getting the same error, but at least we fixed the regular expressions. If this error is happening, oh, you know what? I know exactly what it is. Alright, you see here, we didn't have the dot. We're missing the dot. I think that's it. I think that's exactly the problem. Alright, let's give this another shot. Let me clear this out, try calling it. There we go. Perfect. So these are our commits. You can see we're committing 3 blobs. The hashes are here, and then the files are here. And if we go back to this, let's see. I think we should have a new object. Well, here's the new object with the commit in it. There's also this new master in the refs file. This is the actual commit, which has now changed the actual head that we're at. So this is the new hash that we're synced to inside of our repository. So now if I go back into the command line and add some more files, let's add the file.rs and what didn't we add? I don't know. Let's add like commit, because we did a lot of work on that. All right, and now let's commit them again. And now we've got a parent. You can see here that was the old hash that we were just on. And now we're creating a new tree with these 5 blobs. And that should now give us a new hash that we're on. So let's jump back over. And let's close all this. Let's see. All right, so that's a new hash. We've got a bunch more directories in here. Let's see, where is the, here's the actual commit. You can see here's the parent. Our index should be updating. That's something that I need to look into, because that's definitely an error. Index should be updating with a hash as well, but apparently it's not. So that's something I definitely need to debug. But the rest of it seems to be working as intended. If we wanted to continue with this, it would be a matter of adding the zlib encryption, then adding more commands like the ability to check out the data after we put it back, or check out new branches and stuff, pull data, push data, add remote repositories, do cat on the files, and stuff like that. All right, guys, well, I'm going to close out the stream now. Do you have any questions or comments or anything in general? I'm open to any particular questions, comments, concerns, feedback, just any of it. And let me, while I'm doing this, while I'm waiting for you guys to answer, let me, I'm going to actually add this to the git ignore. And then, well, I'll just commit all this stuff. Ironically, I'm using git inside of a git tool. Anyway. Finished, commit, add, and init. And then I'll push it to the repository. You guys can take a look at it if you want to. All right, so Farhan says, keep up the good work. Thank you. And he enjoyed it quite a lot. I appreciate that. Sorry it was a little confusing, I'm sure. But you know, I think at the very end we got into a nice stride, which is good. All right, it looks like everything was committed. So I'm going to be streaming tomorrow. I still haven't decided what I want to do. Probably be around the same time frame. In fairness to the other subscribers, I think I'll probably go back and do some more Flutter. Or I'll do some Go. I'm not really sure. I'll put up a poll tonight and see what you guys want to see. I'd love to do more Rust, but sometimes it could be like banging my head against the wall with the compiler. John says, awesome stream. Thanks, man. Yeah, no, thank you. And for all of you who are in the stream, if you want to support me, get more live streams like this, you can go check out my Patreon. You can go check out all my other videos. Just watching the videos is enough support, in my opinion. And I never say this, but if you want to, you should like those videos and comment on them and do stuff like that. Even if you dislike the videos, dislike them too. Helps the algorithm spread my videos around. And then more people see them, and that helps. Rust seems a bit more involved than Go. In some respects, it certainly is. It's got more of a functional paradigm than Go. One of the things I hear a lot about Go is that Google deliberately designed it so that it's fairly simple. And so as a result, it's pretty easy to replace people who do Go. Honestly, I don't agree with that. I think it's pretty callous to say that, actually. Go is an interesting language in its own right. Certainly very can be very involved, especially when you start to work with the concurrency primitives and stuff. As far as Rust goes, it's just they're two different domains, in my opinion. You know, they both may be considered quote-unquote systems level programming languages, but the reality is that they're not really. Rust is more like C++, whereas Go is more for like net and for like web-based servers and stuff like that. Yeah, Go is great for web stuff. It's good for things like Docker, like small self-contained systems are perfect for Go. Rust is good at that too, but it's good in a different way. It's got its own little niche in there too. All right, guys. I think it sounds like my voice is killing me, and I should get something to eat. So, thanks for coming to the stream. If you want to check out tomorrow's stream, like I said, I'll have a poll up. You can vote on what you want to see, and yeah. See some of you tomorrow, and I'll see some of you guys later. And it looks like that's it. All right, guys. Talk to you later.